Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with IgniteNet. Today's host is Dan Kazwara. He is their field application engineer, and he'll be presenting today. If anyone has any questions, please submit them in the question box, and I'll ask them of Dan at the end of today's presentation. Dan, I'm finished for now. Thank you so much for taking the time to be with us today. Please go ahead and take it on over.
Okay, thank you, Julie. Okay, thank you everybody for joining today's webinar. So first I want to start off with probably the question you have is, where does it say IgniteNet? This is IgniteNet or is it EdgeCore? So let me first explain that. So EdgeCore is a subsidiary or a separate company that is part of IgniteNet. EdgeCore is both owned by a larger company, Acton. So the product I'll cover today, the Telegraph product, is actually under the brand name of EdgeCore, but it's still the same company ultimately. The experience of working with 60 gigahertz products, the IgniteNet, it's all under the same conglomerate. So I wanted to point that out. And actually, if you've existing customers out there with IgniteNet, you'll notice our cloud has changed. It's no longer the IgniteNet cloud, it's called the EC cloud. And the reason is because now the cloud supports both EdgeCore products and IgniteNet products. So some of the, well, EdgeCore is most well known for high-end data center switches, but they also have some indoor and outdoor access points and some smaller switches, 8 and 24 port regular, say, layer 2 managed switches, which can now be added and managed on the cloud, the EC cloud. So, and one of the big changes, a lot of people don't know, is a few months ago, the IgniteNet cloud would support up to just 2 devices for free. And then you'd have a paid subscription of $99 a year, which is still very reasonable, but the limit was 2. That had changed. Since since it changed to EC cloud, a lot of people don't know, you can now support up to 50 devices for free on the EC cloud, IgniteNet cloud. So that's a big change. I think that's a big improvement, and just to be more competitive in the market. So just want to point that out. So EdgeCore products and IgniteNet products can now be managed together on the EC cloud. So, all right. So today I'm going to be talking about the Telegraph certified solution. Okay. So agenda will be the what is Telegraph. Then I'm going to talk about the MetroLinq product line a little bit as a kind of just to show the history. The main focus today will be the product overview, the Telegraph product. So that's what I'm going to. So the first two I'm going to kind of go through those fairly quickly, and then we'll focus on the product overview, and then the deployment scenarios, and then at the end Q&A. Okay, so first talk about the Telegraph. Okay, so Telegraph is actually was initially put together by Facebook, and so the idea was, well, I'll cover in a little bit, is why would they be involved in any of this? And I'll cover that. But I think, well, this slide shows, and I think a lot of people realize in the industry, if you're in the industry, you know that in the future, the need for greater and greater, faster internet it's ever increasing, and the reasons are got more and more devices, just more and more demand for internet, and specifically higher speed internet. You see demand that it's projected to double in the next 3 years. I think we all know that. We've seen that, and that's what's happening. So definitely need products that can provide even greater throughput ultimately. One of the big challenges, though, even in the United States, you see there's over 1 billion people of outdated last mile infrastructure, but even in the North America here, we got 108 million estimated that have outdated last mile infrastructure. So they might have an internet connection, but it's poor. It's not the greatest connection. It's slow. It's not really high speed or keep up with the demands. And that's where kind of Facebook is their reasoning, or you think, why would Facebook? Well, they have a vested interest in having higher speed connections, so users can use their product, which is Facebook. And you got to have a high-speed internet connection to have a good Facebook experience. Okay, so what is Terragraph? So Terragraph's a multi-node wireless mesh technology designed to deliver reliable and high-speed internet. So similar to the IgniteNet, I'd say in the frequency, it's 60 gigahertz. It's unlicensed. High speeds, we know that the 60 gigahertz space has really wide channels, so super high speeds. The advantage now with Terragraph is that it has mesh. It's using OpenR mesh, so that's an advantage, say, different than the existing MetroLinq. Of course, lower cost to deploy, faster time to deploy because it's wireless. Okay, so how Facebook is helping the OEMs and what their involvement is software and firmware development. They're also, in regards to the OpenR protocol, and it's similar to OSPF as far as the meshing protocol. They're also working with government agencies and things. Even though 60 gigahertz is mostly unlicensed, I'll say some countries it's still licensed or not all the channels are available. So they're doing advocacy to help facilitate so these, Terragraph could be fully utilized in all, hopefully all the countries in the world. And then industry evangelism. So direct promotion and service providers. So in other words, you'll probably see in the future where Facebook's promoting this through their own Facebook, through Facebook. Okay, so for a little more, going over a little more of the technical side of this, so in a little more detail. It's still 4 channels. You'll notice if you're familiar with 60 gigahertz, existing 60 gigahertz, it's there are 6 channels in North America available. 57 to 71 gigahertz unlicensed, and a lot of the world too has access to that. But the worldwide support is 4 channels, so that's why most of the chipset manufacturers in this Qualcomm chipset that's used here, 8211AY, is still 4 channels out of the 6. The resilient mesh there, that's referring to the now OpenR protocol that is and the software and development of that is coming from Facebook. That's handed out to all the OEMs like us, like EdgeCore OEM. Efficient MAC and PHY. Okay, so now it's 802.11ay. So that's the next generation from 802.11ad, 60 gigahertz. The big difference is that where 802.11ad is carrier sense multiple access with collision avoidance, which is similar to just standard Wi-Fi, like 2.4 and 5 gigahertz Wi-Fi, like 802.11ac. This is now using TDMA. So for backhaul and point-to-point, point-to-multipoint, TDMA is much better technology for that. So that's going to be a big advantage, even over our existing IgniteNet products, is that it's TDMA. The radios will have a GPS receiver in them, and it's all integrated from its design. So its design is going to work well. And that's in the scheduling and everything. It's through GPS sync and TDMA. So that's a big advantage. People ask the common question is how many time slots? It's 16 per radio. So you got 15 connections. 15, you could have what we call client nodes or other DNs, distribution nodes. I'll cover that a little bit, but it's 15 per radio, and our big radio has 4 radios, so it's actually 60. It's 15 times 4. So I'll cover some of that when I go over the products. Also, want to point this out, TDMA allows for same channel. So unlike, say, our Omni radio, if you're familiar, has 3 separate radios in there and they have to be on separate channels. With TDMA, now the entire 60 gigahertz network will be on the same channel. So we set them on channel 4, they're all on the same channel, thanks to TDMA, which is going to be nice for channel reuse and channel bonding, which would normally take up, it does take up another channel, but you'd be worried, oh, I'm running out of channels. No, you're not, because TDMA, you're on the same channel, so you can get away with channel bonding. devices will be able to be managed on the cloud. Network planning. Okay, so Facebook actually has what they call the Advanced Network Planner, which will allow for helping in deploying or design networks, especially from their words is say people, installers that are new to installing millimeter wave technology, which could be some unique challenges, say. So it should help facilitate them in designing their networks and learning what to do. Okay, so the Terragraph use cases. So some of these will probably look familiar, like for example, the first one, fixed wireless access. So that's figure an alternative to, say, running fiber. That's kind of an existing thing, say, with our existing IgniteNet MetroLinq product, right, where you would use our radios to do a point-to-point link in lieu of, say, or when you're unable to run a fiber run. Big advantage of 60 gigahertz is the very high throughput, but also the fact that it may be, well, a lot of 5 gigahertz is saturated. So it's a very low interference, or basically virtually no interference on 60 gigahertz. So you could use 60 gigahertz as an alternative to 5. So the same case with the Terragraph product, but the advantage is it's now could be meshed, and it actually has even higher throughputs and higher performance. Other applications that might be kind of unique now, I'd say now with the Terragraph, which may or may not be exactly a perfect fit beforehand with MetroLinq, is like, say, mobile backhaul. So street level backhauling cellular mobile sites like the 3G, 4G, 5G now especially. So backhauling, you have mesh and very high throughput and connection, but the mesh I think is the big game changer in this case. So you could put them, say, on street furniture and hang them in, say, for example, 5G, where you have small cells. You could say a big advantage of that over before, where there wasn't really mesh integrated. Outdoor Wi-Fi. So outdoor Wi-Fi, say, for a city. Another example, when it comes to outdoor Wi-Fi, I can think of is like an RV park or a mobile home park, where where mesh really could do well. Like it would shine if it had a large, big backhaul, and then each radio could then you could hang, say, a 2.4 and 5 gigahertz radio off of that, below. And then smart city is example, like, say, CCTV cameras, etc., in the city. Examples. I'll actually have another slide on this I'll cover. Okay, a couple cases for fixed wireless access deployments and successes from before. There's actually been some use cases already deployed, and the big takeaway from this, what they found from these deployments, and I want you to take away from this, is that the big advantage is the lower CapEx and the deployment time. Probably the deployment time, if anything, was which was a huge advantage. 4 weeks, the other one less than 2 weeks. So think about that compared to what would have been, something that might have taken years. And then availability, thanks to the open R and mesh, its availability is 3 nines, even though it's all 60 gigahertz. Okay, now I'm going to go over the products. So the EdgeCore, the products. Okay, so the first thing I'll start with is the existing MetroLinq, and this is something that's currently available and started in 2015. First product actually to deploy 802.11ad was IgniteNet. So the first to, at a low cost option, the unlicensed 60 gigahertz band using 802.11ad chipset to provide 1 gigabit at 1 kilometer. Since then, there have been improvements. The ML2.5 is it's a similar radio, same frequency, 60 gigahertz, but it has a 2.5 gig Ethernet port. It handles more packets per second. There's the 10G Omni, which is probably one of our most popular products right now, is the Omni. So it's 3 120-degree sectors to provide 360 degrees of coverage. It's got 10G SFP plus port connection. and now the Teragraph certified. You have an AY product that's coming now. Okay, so there's two main models available or coming to be available very soon, like in the next availability. And I know this question is, when can we get this? It's December now, early December. It should be hopefully in the hands of distribution by the end of this month in early January. So very, very soon. So there's two main models. There's the distribution node and there's the client node. So first I'll cover the distribution node here. And if you're familiar with the existing Omni, if you've done, say, IgniteNet before, it's kind of similar in some ways, but it differs in other ways. The existing Omni, or even the BF18 or LW models, they use the Paraso 710 chipset. It has 8 tiles or elements, and the gain is about 17 to 18 dBi, and had 14 dBm of output power. The antennas were 120 degrees. They beamformed though down to 10 degrees. Horizontally and vertically was fixed at 35 degrees. So no matter what you did, it was always 35 degrees. Those are our sectors. That's the existing IgniteNet. Now this guy is a little different. So this one's 4 90-degree antennas. They have 64, actually that's a typo in there, it says 256. It's 64 antenna tiles per radio. There's 4 radios, so it's actually 256 total in this radio. But 64 allows for more directivity of the beam forming. So it's actually down to 1.5 degrees horizontal and 10 degrees vertical, which gives it around 22 to 23 dBi, about 6 more dB gain, which gives it more range. And it actually has a higher output power. I think it's around 20 dBm or so compared to the 14. So that's an improvement as well. Other things to note, let's see, the throughput will be around 1.8 gigabit in one direction, or aggregate of 3.6. And you'll see that consistent with all Teragraph stuff, because it's all, whether it be EdgeCore or another manufacturer, you're going to be on the same Qualcomm chipset. And the PHY rate, the physical rate is 4.62, but the actual throughput is going to be 1.8 one direction, 3.6 roughly in aggregate in both directions per radio. Okay, so there's 4 radios in here, so you could factor it's actually 1.8 times 4, or 7.2 gigabit if you count all 4 radios. Now each radio has 16 time slots minus 1, 15. You could have 15 clients off one of the 4 radios. There's 4 radios, so 60 clients. That's an improvement over our existing Omni as well. The TDMA is also going to improve performance. The GPS receiver is on the top of the radio. Please note any questions you have for this. I'm sure there's other questions you have. Oh, the up to 250 meters, I wanted to mention that. That's from one distribution node to another distribution node. Like I mentioned, there's 2 products. The other one's the client node, and the client node to distribution node distance is 150 meters. I know that's going to be a question that many people will have. Okay, the MLTG-360 is going to just have one mounting bracket. This is it. So it will allow you to mount on the top of a pole, the side of a pole, or pretty much any street furniture. So just one bracket's needed and available. Okay, so I mentioned the 360 degree, the 4 radio model. There's actually going to be 5 different part numbers that is under as a distribution node. So there's 2 models, like a distribution node and a client node, but there's 5 part numbers of the distribution node depending on what your needs are. So I mentioned the 360, but there's also going to be a 270, which would be like an example here where you don't need this direction. So you're saving a little bit of money by having 3 radios instead of 4. You also have the 180. Now there's going to be 2 180 models. There's going to be one that's 90 degrees opposite each other, like one say face north and the other one's east. That's how the radio will be built. or there'll be one that's faced opposite each other, like north-south. So there'll be two 180 options, and then there's going to be a 90 degree. So the total is going to be 5 different radio options. So two of these, one 270, one 360. So keep an eye out for that depending on your needs. You see this in an example. You can see the needs are different depending on where you're mounting these and installing these distribution nodes. In this example, the max distance is about 250 meters. And then with TDMA, they're all going to be running the same channels. So transmit, receive, TX, RX, that's how it's going to be working. But the beauty is all this will say be on channel 4. It'll be a big advantage compared to before. Easier for deployment. Give me one sec here. There we go. Okay, now the client node. So the client node, it's very small and compact. I mean, we're talking, you got one here. It's about maybe 8 inches by 4 inches by 1 inch deep. It's really small and light, probably around a pound. It's basically one of the radios, the 90 degree radios like the DN has in it. It also, I want to mention, it's a 90 degree coverage. It does beamforming down to the 1.5 degrees. So aligning it's real easy. You just kind of point it at the general direction, you should be fine. The vertical coverage is 50 degrees, plus and minus 25 degrees. So that's pretty good too. So like I said, you just pretty much point it and you're good. One thing I want to point out about this product, and as of this time right now, I guess it could change, but it is going to be the most price competitive client node for Terragraph out there. Right now, I think it's the lowest priced, most price competitive client CPE device for a Terragraph. So keep an eye on that. Okay, so there's going to be a couple different mounting options for the CN. The client node is, you got basic hose clamps that come with it. Self-explanatory, and like I said, it's real forgiving. 90 degrees horizontal by 50 degrees plus or minus 25 degrees vertical, so pretty flexible. We do have another little bracket which maybe for certain reasons you'd go with this. You do have some vertical rotation plus or minus 20 degrees on that, so if there was a huge amount of height difference or something, or had a reason to rotate it vertically, that you see on the right there, it's vertical rotations plus or minus 20 degrees. There's also a third option, which you may see that bracket look familiar. It's similar to the standard, or it is the standard, original standard bracket, MetroLinq. That one allows full flexibility. I mean, you could actually mount, rotate this basically 90 degrees horizontal and 90 degrees vertically. So it's quite a bit of rotation ability. Okay, I mentioned earlier some deployment scenarios. So there's a couple slides on them. So the distance, I just want to point out, is 250 meters. Now, you say that's not as far as before, but let me explain. There's no aiming, right? This is beamforming and going 250 meters. So it's actually much further than our existing. Let's say if you were to mount an Omni to another or have one Omni talk to another Omni on the existing MetroLinq, the distance is only about 50 meters. You really need a higher gain client node or client a CPE like our 35 centimeter or 19 centimeter to point back at it to get that distance. So this is where it's a shorter distance, yes, but it's self-aligning and self-connecting, self-aiming. Let me correct myself there. Okay, so 250 meters, and then you got the CNs, and that's 150 meters. So in this example, you got 3 to 1 and then 1 to 1. Okay, then the outdoor Wi-Fi backhaul. So as somebody asked, can I put an access point? Can you do cable drops on the DNs? Well, certainly can. You could do both. Let's say you have a DN here. Let's say your internet's coming here, and you have a DN here. Well, you could certainly do a cable drop from the DN down and run a Wi-Fi access point here off the DN or a CN. Either way, how you want to do it. The reason why you have this is because you're distributing again, meshing, connecting or here. So You could have a mix of DNs and CNs depending on your need. Small cell backhaul, I mentioned that. So just an example where basically it's similar as before, but instead of a access point, you have a small cell, let's say LTE cellular technology instead. And then the smart city example, where you could have, say, other technologies, like I said, CCTV and stuff like that for, say, a closed network, say, for a city. Another thing to point out, so what about longer range? Okay, so I want to cover two things are mentioned. Okay, so first thing is, yeah, you could, people ask, can I use existing MetroLinq? Okay, obviously there's no interoperability with the existing MetroLinq products. It's a different chipset. It doesn't, the old stuff doesn't use TDMA. It's not going to communicate directly. But you could certainly use an IgniteNet, say ML, this example, it's to be like an ML 2.5 6035, which can go up to about 2 kilometers point to point. You can certainly use that. And those are layer 2 transparent bridging. So anything you're doing through the teragraph will be included in the, you know, because it's layer 2 transparent bridged. Any traffic that, say, is in there can be passed along without any issue. In the future, though, we are working on getting a very directional, high gain product to work, and that'll be our third product. I mentioned there's a CN and DN, but there'll be another CN coming. It won't be for some time, maybe I think it's estimated around Q2, for a high gain client node, so look out for that. And then the big advantage of that is, so the existing MetroLinq can go about half a kilometer point to multi-point. So that means you get a 35 centimeter radio, high gain, pointed back at the Omni. You can go what we recommend up to about a half a kilometer. We're hoping for 1 kilometer point to multi-point. Be a game changer. That'll be huge. So up to 1 kilometer because of the higher gain of the DN, right, and higher output power from before. That's the goal. Okay, and that concludes my presentation. I'll turn it back over to you, Julie.
Thank you, Dan, for that wonderful presentation. And yes, it looks like we've got some questions here for you. Let's get started with the first one. Okay, here we go. Will Teragraph devices work with IgniteNet devices as well?
Not directly, but they can be utilized in the same network, kind of like what my example just recently, you know, just a slide ago was. You could integrate them, but the meshing obviously wouldn't work. It's just going to be like a point-to-point. Honestly, at that point, it would be treated like a separate vendor's product at that point. But they could certainly work with each other. The only thing, obviously, you'd have to be taking into consideration is channel reuse. Where the Teragraph, it's all using the same channel, which is nice. So let's say you all set the entire Teragraph network to channel 4, then obviously you'd want to set the IgniteNet to a different channel to avoid interference to the Teragraph network. But other than that, yeah, it should work.
Thank you very much, Dan. Next question here for you. Are there multiple options of Teragraph units?
What does that mean? Sorry, optional.
You know, I'm not sure. Let's just go ahead and go to the next question.
Okay.
Next question here is, will Teragraph related questions be supported by the team of IgniteNet?
Yes, I believe so. We are working together, so I'd say yes. If you have a question and you were to, let's say, email IgniteNet, yes. I mean, we're going to be EdgeCore. If you emailed EdgeCore or if you email IgniteNet, ultimately it's the same team that we're going to be trying to help each other and you guys out there. We either way would get it. Yeah.
Excellent. Thank you. So for that tech support, is there an email address that is useful Monday through Friday? Can you expand more on the support?
Yeah, you could do support at IgniteNet.com, or you could do support at edge-core.com, either way.
Excellent. Thank you so much for that. Next question here for you. What is the backup for the 60 gigahertz units?
Good question. There isn't one. There's no 5 gigahertz failover or second radio for failover with Terragraph, unlike the MetroLinq, which has the 5 gigahertz. The reasoning, I think, is that you, in theory, shouldn't need it because you have now mesh. And like the example where the use cases where they had 3 nines, 99.9% up, is because you have multiple connections. And also keep in mind, at shorter distances, like 250 meters and less, you're much less prone to signal fade with rain and things like that because it's such a short link. Because attenuation for rain is additive based simply on distance, right? So even heavy downpour, but you're only at 200 meters of a link, there's not going to be that much in the way because it's just not that far of a link. So you're not going to have as much signal fade as, say, a 1 kilometer link. You'd have 5 times more signal fade at a 1 kilometer link than you would at 200 meters, right? So that's kind of the thing. And also you should have some redundancy if you're doing a mesh network. So that's kind of the idea. Now, if you wanted some additional failover, then you could certainly design your network like a lot of the WISPs do or installers do. You could always use OSPF or some other technology to do that and use a separate radio to do that. But that's not what Terragraph's purpose was. It was the open R protocol and the mesh to really create resiliency and redundancy and utilize really the big benefit of having mesh.
Thank you, Dan. Next question for you. Does IgniteNet offer anything in 11 or 7 gigahertz?
No, it's only 2.45 gigahertz and 60 gigahertz.
Thank you for that. Next question for you. Can you share again what Facebook does for OEMs?
Well, there was a slide on that, but it's really providing the software coding for the OpenR protocol, and that was the big thing, is getting this, in a sense, getting the motivation for manufacturers to produce a product that will get this together and utilize the mesh and the integration with the new product. Let's say the new chipsets that are coming out, like the Qualcomm, specifically the Qualcomm chipset. I think that's the main thing. I mean, I'd say if you want more information on that, definitely just go to the website they have, the terragraph.com website, and get more information directly regarding that on Facebook's Terragraph website.
Thank you, Dan, for that. Next question here for you. Does IgniteNet offer bridge kits with 2 units in one package with scope and mounts?
No, we don't, as a manufacturer, include any bundles, but that could be possibly something maybe at the distribution level, but not as at the factory. We just sell individual units or package them as individual units. But that makes sense to have. Yeah, that would make sense to have a pair and a scope, right? That actually does make sense. I kind of like that idea.
Thank you, Dan. Okay, next one here for you. When the Terragraph device is set up via mesh, will there be a download or upload cut in speed?
When it's meshed, well, there is some. It depends. Okay, so yeah, mesh has overhead, obviously. Now, if everything's going through one connection, then everything's coming back to the same internet connection. One thing you could do with mesh, of course, is have multiple internet points of presence. So I didn't really show in this slide, but let's say, or the slides I showed earlier, but let's say you have, I don't know, 15 distribution nodes, and 3 of the distribution nodes have internet access, right? You have connection to them. They're POPs. So like, we'll figure then the OpenR and mesh protocol should do not just the shortest path and best path. Well, best path, best internet connection. You could then it should be, it should do the work to, provide the best latency times, reduce, the lowest amount of latency times and the best throughputs. And as you have multiple connections connecting to your network, so that would be an advantage if you're. That's where it really would shine, is when you do have multiple points of presence across the network. So then the mesh protocol can do what it does best, and say, let's say one path bottlenecks and not doing as good. You might do more hops, but it's a better connection, and then you'll throw more users over that way. So that's just an example.
Excellent, Dan. Thank you so much for answering all of those questions for us today. And also, thank you to everyone for attending today's webinar. And if anyone has any further questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any products mentioned or shown here today, please visit us at www.microcom.us. And please also remember that the presentation has been recorded and will be uploaded to our YouTube channel so you can view it again on YouTube, of course. Thank you, Dan, so much for your time today. I appreciate it. Everybody have a fantastic day ahead of you.